Good morning, good evening, wherever you are. My name is Mark Borstein. I'm co-author of Kubernetes and Enterprise Guide, second edition, along with my partner in crime, Scott Zarovich. Today we are going to start chapter 5, Authentication. Now, this chapter is near and dear to my heart for a couple of reasons. One, it's the first one I wrote by myself. And two, it's authentication, which anybody who knows me knows that I can just talk authentication for hours and hours. Now, I don't want to make this video hours and hours long, so we're going to cover the first two labs, which is getting OpenUnison up and running to do Kubernetes authentication using OpenID Connect, and then switching it over to impersonation and using impersonation for authentication. And then next week, or whenever we record the next video, we'll cover the second part, which will be pipeline authentication. We'll cover generating certificates to use in pipelines, or how you can authenticate securely to a pipeline without using a service account. My favorite thing about this chapter is that we really dive into the nitty-gritty of authentication, why you should be using OpenID Connect or impersonation with OpenID Connect, why you should avoid certificates. In the notes on the video, I'll have links to a bunch of videos and blog posts I've done as to why you should not use certificates for your clusters. And then we'll talk about a little bit of RBAC, just enough to show you how it kind of comes together. We'll cover RBAC in the next chapter, though, in much more detail. And we also talk a little bit about one of the things I find really exciting is, and I understand that there's something wrong with me for finding this so exciting, is the fact that Kubernetes is moving to token request API. When we wrote this edition of the book, there was no way to use the token request API from kube control. Next edition version of kube control actually has a token verb, so you can generate tokens on the fly. So whenever we do third edition, that's definitely making it into the book. But without ado, let's go ahead and, while you're here, have fun with some labs. So I started off with a brand new cluster. There's not a whole heck of a lot in it. And what I would recommend is from this point forward, really whenever you're going to start the labs, start with a fresh cluster. You're going to make yourself a lot happier. And as we move through the labs throughout the rest of the book, whenever there's something you need from something earlier in the book, we just give you a script to redeploy it. So for instance, in this chapter, we're going to deploy OpenUnison, and we're going to go through each step individually so that you can understand what's actually happening, how the different pieces work together. But next chapter, when we get to RBAC and you need OpenUnison, we're just going to scrap this whole thing and run a script, and OpenUnison is going to be up and running for you in about 10 minutes, all automated. So don't feel intimidated or worry that you have to keep these clusters up and running so that you can move forward. We wanted to make it so that every cluster was kind of idempotent. You could get it up and running on its own. So that said, one of the first things we actually do in this chapter is we go through all the different authentication mechanisms, and we talk first about service accounts. And so the first it's kind of a mini lab where we create a service account and use it. So I'm going to go ahead and create a service account. I'm on page 174, by the way. And then the next thing I'm going to do is get the secret. Now, here's this. Am I going to have to? Nope, it should just work. Let's see, will this just work? No. All right, let's see what happened here. I think, oops. We'll get this to work and then we'll walk through it. What's going on here? Because there's a lot going on here. There we go. Okay, so let's talk about what's happening here. So first thing we're doing is we're getting our secret. And so this notation here is where some of the fun is. So this notation here is Unix saying, all right, we're going to get the service account, and we're going to get the secret name out of the service account. So the service account has the secret name in it. So when you create a service account, the token that gets generated is a secret, And the service account actually has the name in there. So like if I do this manually, oops, right? So service account references the secret. And the secret's got this random nonsense at the end of it. So then what we're doing is we're saying, okay, once we get the secret name, let's go ahead and spit that out into JQ. Now, JQ is a Swiss Army knife for JSON, for managing JSON. So it's a tool that you will likely become quite proficient with, or I will at least recommend becoming proficient with. It can really do a lot of great things. I don't do it justice in most of the book. I use it for really simple stuff. But it's an incredibly powerful tool with working with JSON on the command line. So once we have our secret, we then go ahead and export the token out of the secret, base64 decode it. So that gives us this big giant blob. Now, this is a service account token. It's static. If we go ahead and let's, do I have Firefox open? Let's go ahead and fire up a new Firefox. Yeah, make sure that we can see it. So I'm actually going to take this token and drop it into a tool called jwt.io, which will decode JOTs for you. So let's take a look at this token real quick. And this is typical of service account tokens, static service account tokens. It says what the namespace is, the name of the secret, what the service account name is. Notice what's not here. There's no expiration time. So as you're reading through the book and we talk about how OpenID Connect works, you'll see that tokens have expirations, not service account static tokens, which means that until you delete the secret associated with this token, it'll work forever. And so that's dangerous because these tokens, they get leaked pretty easily. We'll talk about that more when we get to pipelines. But I wanted you to see that before we get into OpenID Connect, because a lot of people are going to say, well, why do we go through the pain of OpenID Connect? OpenID Connect can be painful to integrate. And I think we've done a pretty good job of making it easier. But why do that when I can just use the service account token? Well, this is why. There's no expiration. The service account token works forever. And I'll have a link. I'll have links in the notes on this video as to why you shouldn't use service account tokens as well, in addition to what we have in the book. So let's go ahead and see what we can do with the service account. Just to give you an idea. So the first thing we're going to do, let's clear this, is let's go ahead and I need to know. All right, let's take a look in our kubeconfig. 6443. All right. Try this. 6443. Ah, that worked. Okay. So you can see here that we were forbidden because we weren't authorized. Like system anonymous was not authorized to call /API. So now let's go ahead and do the same thing, but this time we're first going to get our token. So this is going to look pretty familiar. This is the beautiful foo that is dealing with Linux. Oops. It won't work, which is okay. Now let's go ahead and clean it up. Oops. All right. So what we did was we got our kubeconfig token. So that original command that we ran that spit out that base64 token that we dropped into jwt.io, we put into the kubeaz environment variable. Except I don't know how to type. It's late. It's been a long day. Okay, so there's our there is our service account token. So now that we have a service account token, let's go ahead and do the same thing we did before, but instead this time we're going to go ahead and embed our service account token. Authorization, bearer, I think it's called KubeAZ. So we're telling curl to create a header called authorization that starts with the word bearer, a space, and then our service account token. And this time, this is what it ends up looking like over the wire. And this time you can see we actually did get a response. So that is how you use a service account token, by embedding it into the request as an authorization header. This is what's called a bearer token. Because we have the token, we can do whatever we want. Think about this like a ticket to your favorite stadium for a sporting event. Most of the time you get that ticket. It doesn't have your name, it doesn't have your picture, it doesn't have anything on it, just that says, here's your ticket to get in. You pick up that ticket, you bring it in, you drop it somewhere, someone else picks it up, you got nothing. And bearer tokens work the exact same way. There have been attempts to try and tie bearer tokens to a TLS connection. Those attempts have, for the most part, failed miserably. They've never gotten much traction. So that's all we're going to talk about service account tokens as far as labs are concerned. We then talk a little bit about token request API. We touch on custom authentication webhooks. Don't do them. But just don't. Unless you are a cloud vendor and you have your own IAM system to use. And honestly, we'll talk about this more about impersonation. You probably want to use impersonation anyway, but we'll have that conversation later. But just no to custom authentication webhooks. All of them end up looking like pale imitations of OpenID Connect or Pass the Password. OpenID Connect is a well-vetted standard, thousands of hours of review, thousands upon thousands of implementations. It ain't perfect, it ain't always easy, but at the end of the day, people understand how it works and it's been vetted. Your custom authentication system probably will not. Keystone, actually don't really run into Keystone much anymore. Folks that used Keystone used OpenStack, especially in the earlier days of Kubernetes, when you would deploy Kubernetes on top of OpenStack, they would use Keystone. Keystone was the LDAP or the authentication system for OpenStack. And so let's go ahead and get to the fun part, which is configuring our cluster for OpenID Connect. So we are working at Fake Enterprise, and like most fake enterprises and real ones, they have Active Directory. So what we're going to need to do is integrate our cluster into Active Directory. It's very common. And we're going to do so using LDAP. We want to make sure that we can provide roles from our directory into RBAC so that we're not manually managing our RBAC permissions. And we want to give dashboard access. There are a lot of people who say, oh, the dashboard is insecure. Nonsense. The dashboard is only as secure and insecure as you deploy it. We're going to get into an obscene amount of detail as to why that is true in, I want to say, chapter 7. And the reason why it's really important to understand the security of the dashboard is that your cluster is going to be made up of more than just your API server. Your cluster is going to be made up of dashboards, front ends, monitoring systems, all sorts of different GUIs that all want to interact with the API server. And so understanding how your users interact with those applications and how those applications interact with the API server will let you deploy them more securely. So we'll dive into that in chapter 7. And then finally, of course, CLI access. We gotta have kube control, right? It ain't all just dashboards. So we're going to pull it together. There's a couple of really nice diagrams, and let's go ahead and start deploying OpenUnison. So I am on page 182. So real quick, what is OpenUnison? OpenUnison is Tremolo Security, which is my company. Tremolo Security's open source project for managing for authentication, authorization, user provisioning, all that great stuff. And what we've done is we've created a platform by which you're able to roll out your authentication into your cluster in such a way that is not just for your cluster, but for your other applications as well. And when we get to the end of the book, chapter 14, we start talking about GitOps and automation. We're going to use OpenUnison's namespace as a service functionality. So that said, I'm on page 182. And first thing we're going to do is deploy the dashboard. Oops. And because good old copy and paste. All right, so we've gone ahead and deployed the dashboard. We've gone ahead and deployed the dashboard. So that's the easy part, right? There's nothing going on there. So now the next thing we got to do is, let's go up here, is we need to deploy our Active Directory. Now, I don't actually think you can run Active Directory in a container. That would be kind of meta. But what we did was we packaged a Active Directory for you. So that way you don't have to have any kind of external dependency. You don't have to have anything set up outside of your environment. So let's go ahead and deploy our Active Directory. There we go. Isn't Kubernetes awesome? So Active Directory is rolling out. We'll give that a couple of minutes. So do I have Helm installed in here? I do. Great. So next thing we're going to do is start deploying add the OpenUnison repo locally. And probably already have it, but let's run this command anyway. Yep, already do. And then let's update our repo. So we're pulling down all the latest charts, make sure that that's up to date. Now that our repo is set up, let's go ahead, and I'm on page 183, step 5. Kube control, create namespace, OpenUnison. This is where OpenUnison is going to run. And then we need to have a little bit of a custom directory integration for this. Just because this isn't a real Apache DS, we actually decided to do things, or a real Active Directory, we're using Apache DS, which is a nice little project from Apache Software Foundation. It's a nice, simple LDAP server. It's written in Java, which is one reason I really like it, really customizable. And so what we need to do is actually adjust how we're going to talk to AD so that works with Apache DS. So this is step 6, and this is just a YAML. Let's go ahead and take a look at this one real quick. Chapter 5, MyVD book YAML. So this is just an embedded config map with MyVD configuration. Not really a ton going on here. It's just we adjust some of our mappings inside of Active Directory. You don't really need to worry about that. So our next step is to set up the operator. So OpenUnison has an operator. That operator is responsible for setting up, what's the operator responsible for? So the operator is responsible for watching for OpenUnison objects that get created, generating key stores, and then whenever you update that OpenUnison object, redeploying OpenUnison. It also creates a webhook for validating custom configurations, and we'll see that more, especially once we get into chapter 14. So let's take a look. We want to wait for the operator to be running. And it is. Cool. So next up is we need to create a secret. Now, what I will say is that never, ever, ever embed secret data directly into a CR. Always rely on secrets. Why? Well, for one, it's not because they're encrypted. It's because it makes it easier for you to define your RBAC policies. Um, if you want to externalize your secrets, there are great tools from the Secret Store SIG for synchronizing from external secret systems like Vault or the various cloud Vault systems directly into a secret. It's a standard. Use it. Um, so let's go ahead and is this actually going to work with the indenting? No, of course not. So let's go ahead and just going to do this off screen because I'm really lazy. Although they say the sign of a good developer is that they're lazy. If that's the case, I got to tell you, I'm the best. No, most certainly not. All right. Let's go ahead, paste that in. Okay, cool. So our secret's been created. What's in our secret? Unison key store password. So this is the key store that gets generated by the operator. You want to be able to set this password because if you need to debug, make sure that there are things in that key store that get generated. You're going to need to know that password. Our AD bind password. This is the password that OpenUnison will use to talk to Active Directory. And then the Kate's DB secret we can ignore for now. That'll come up in chapter 14. All right, so I'm wrapping up page 184. And let's just do a quick heartbeat here on our cluster. Oops, before we go too far. And then kube control get pods and Active Directory. All right, cool. So our testing AD is running. So the next step is we need to update our YAML file. So if we go to chapter 5 and we want to edit OpenUnison values YAML. So the only thing that really changes in here is we got to update our IP address for our various hosts. So I'm going to go ahead and update this to my Docker or my kind cluster IP. And this is really where the magic's happening. I need to fix this so that we are running off of the latest, but I will do that on my own. Kube OIDC proxy latest. Now, that said, so this is the values.yaml for our first Helm chart. This is really the lifeblood of the OpenUnison configuration. First, we've got our networking side. Where's OpenUnison? How are we going to talk to the dashboard? We'll get into the API server host when we get to impersonation. The Kate's URL, so how are we going to connect to Kate's? Do we want to create ingress controllers? What kind of ingress controller are we using? And then we get into impersonation configuration options for the dashboard. We can embed our certificate directly into here for our Active Directory. We configure Prometheus, which I don't think we're actually using anywhere in this in the book. And we could also set up policies, network policies if we wanted to. Here's our Active Directory configuration. We're going to talk to DC domain, DC com. This is our service name that's running inside the cluster for our Active Directory. Here's the name of our service account. So that's all good. And then let's go ahead and deploy Orchestra. Orchestra, Tremolo, Orchestra, namespace, OpenUnison, F, chapter 5, OpenUnison values.yaml. So what this first chart is going to do, is going to set up our infrastructure. So it's going to set up our OpenUnison object. That'll deploy OpenUnison. If we were using impersonation, we deploy those containers as well. It will also set up our webhook configuration to validate configs for the application platform we're going to deploy. So once we're done with this, our containers will be running for OpenUnison. All right, cool. So that's deployed. Now let's go ahead and control get pods and OpenUnison. So that's creating those containers are going to pull down. We're going to take a short break and a word from our sponsors while we wait for that. All right, just kidding. We don't have any sponsors. OpenUnison's up and running, and our last step, and I'm on step 12 on page 186. Those following at home is we're going to go ahead and install the Orchestra login portal. So now the difference between Orchestra and Orchestra login portal, the Orchestra chart deploys the actual containers. The login portal deploys the application configurations. So OpenUnison has a base container, and then everything is configured through custom resources. So your various applications, your workflows, your identity providers, your interface, all these things are configured separately. And so we've got the container deployed. Now that we have that deployed, we can go ahead and deploy all those CRs. And OpenUnison is going to pick up all those CRs and configure itself into a login portal. So this is a very large chart. The chart itself takes a little while to run, but once the chart is run, there's no more like restarting or waiting for containers, right? So that's deployed. We should be ready to go. So let's go ahead and give this a test. And actually, we're going to keep jwt.io open here. And then Kate's OU. Oh, let me look at my chapter 5. Oh, okay. I know what I did wrong. No apps. All right. Okay, cool. So we're at the login screen. Let's save. Awesome. So we are now signed in. If I click on my name up here, you can see I've got a couple of groups. We'll talk about how we'll integrate that into RBAC here in a moment. And let's go over to the dashboard. And we're signed in. I'm going to make this a little bit bigger, make it a little easier to see. You got this big one red up here, open notifications, unauthorized. This is because even though OpenUnison is deployed and it's ready to go, what we haven't done yet is actually told Kubernetes, hey, let's go ahead and trust this OpenUnison identity provider for our tokens. So let's do that next. All right, so we are on page 188. So the first thing we're going to do is we need to go ahead and get our CA certificate. And once again, copy and paste, have a PDF. Okay. So we're going to go ahead and send this to here. All right, so what we just did was we generated our CA certificate. So we're pulling that right out of the secret that we created when we deployed OpenUnison. And this is so that the API server knows to trust OpenUnison's TLS connection. So if you're running this on a live cluster, and let's say you had like Let's Encrypt, you could actually skip this step. So the next thing we're going to do is let's copy this. And I'm going to do this off screen. Oops. So we're going to use, remember we're running kind, so Kubernetes is actually running inside of Docker. So we're going to copy that PEM file into our control plane container. So now that that's done, we can next go ahead and let's configure our API server. So when OpenUnison deploys, it actually generates your API server configuration for you. Now this step will be different depending on what Kubernetes distribution you're using. This assumes kind, but if you're using canonical, it's a little bit different. If you're using any of the commercial vendors out there, it's going to be a little bit different. So check with your vendor or project if you're using something other than kind or kubeadm. So that gives us our configuration, and here are our settings. So the issuer. So this is our identity provider, and what's really cool here is there's something called the OpenID discovery document. Now, OpenID configuration. So this is what Kubernetes queries to get all the different endpoints, including where all the URL, all the user info, tokens, all that good stuff, and where to get certificates from. So this keeps you from having to copy certificates, rotate them, etc. If you want OpenUnison to generate new keys, you just generate it, tell OpenUnison to do that, and the API server is going to pick them up. So you're not constantly copying things back and forth. And then client ID, Kubernetes. So this is how Kubernetes identifies itself to OpenUnison. What's the username claim? We'll take a look at that in a second. Where the groups come from, and finally, where's the CA file coming from? So we are on page 189. And let's go ahead and get into our control plane. Get update apt get install vim. And we'll be back in a second. All right, and we're back. We now have vim. So we can go ahead and edit this file, which, to be fair, it's a container, so we're not really supposed to be editing files, but, YOLO. All right, so let's go ahead and add our configuration. You know what? I should have done, we can just do this again. Copy that. And we're going to go ahead and add this here. So this is where you configure OpenID Connect. OpenID Connect requires you to have the ability to change the parameters for your cluster. Now, why can't you configure OpenID Connect using a CR? Because the Kubernetes team decided that this is something that should be done by cluster operators, not necessarily by users. So it's really up to cluster operators to decide whether or not you should be able to do this. That is why most managed clusters do not support OpenID Connect, or they support it in a limited way. For instance, EKS now supports OpenID Connect, but you have to have a publicly accessible identity provider. So we've configured that. And now the really cool thing is that it's meta, right? Kubernetes is running inside of Docker, but Kubernetes control plane, the API server, is not just an executable inside of there, it's actually a container inside the container. And so it actually runs inside of Kubernetes. And if I knew how to type, this would have been a much cooler thing to do. There we go. So what we're actually going to see is that there are pods in Kube's system for our API server. And if we look for API server here, there it is. And it should have restarted. It doesn't look like it necessarily did. So let's see what happened here. Okay, that looks all right. I wonder if I have to delete the pod. No, let's see if this worked. Most certainly did not. Oh, wait, no, yes, it did. Okay, so they must have changed what it looks like then, because the pod clearly restarted, and now instead of getting an error message unauthorized, we're getting this error message that our user cannot list the resource namespaces in the API group at the cluster scope. This is now an RBAC error, which means Kubernetes knows who we are. You'll see here that we've got this funky username where it's our identity provider issuer pound username. That's because Kubernetes, at one point there was this thought that Kubernetes was going to support multiple identity providers, so they wanted to have a way to be able to break it up. If you use email email as your username claim, which you should never do, this doesn't happen. Because emails have a domain in it, so the thinking was, okay, well, there's a domain in there, that's a way to break it up. Don't ever use email addresses as your user identity. It's definitely an anti-pattern. Names change. People change their names all their time for different reasons. Once a name changes, now you got to go back and completely redo their authorizations. It's quite painful. And then once we get into RBAC, we'll be talking about why you don't want to use usernames inside of your RBAC policies. And that's a great reason. Imagine you want to change your identity provider URL. Well, guess what? You now have to redo all those RBAC bindings because your issuer is in there. Do your RBAC by groups. We'll cover that in the next chapter. So SSO is working. And so the next thing we want to do is let's just go ahead and create a role that makes this usable. So I'm on page 190. Of course, for some reason, copy and paste or select's not working. There we go, that's better. And since for some reason copy and paste does not preserve spaces, go ahead and clean this up off camera. No, actually it doesn't change. That's actually not a big deal. Nope, that actually stays there. All right, so let's come back here. Oh, nope. Let's get out of our container. So we're creating a really simple, almost. So we create a really simple cluster admin role that matches on our group. So anybody who's a member of this group in our Active Directory is going to have access to our cluster as a cluster admin, which obviously not particularly safe, but we now have access to our entire cluster. So we can take a look at basically everything. Let's take a look at nodes, what's going on in our nodes, everything's great. As I say in the Lego movie, everything is awesome. So now we know that the dashboard works. Well, the good news is if the dashboard works, the API is going to work. So let's come over to kube control. So once we're logged in, we've got this great little Kubernetes token key here. So this opens up a screen that gives us a lot of information. 99% of the information we can ignore. The nice thing is we generate kube control commands and kube control Windows commands for you. I'll also show you the ID token. So let's take a real quick look at that. Never do this. This is a dev box, so it's okay. But again, these are bearer tokens. So if you paste this token into a website, it takes that token, uses it against your cluster. Everybody's having a really bad day at that point. So here is, I'll make this a little bit bigger so we can see it a little easier. Here is what is inside of our token. And here are the two important parts. One, the sub. So that's who we are. That lines up to what we saw earlier in the error message about the username. Where'd it go? Over here. And then groups. So you remember that we added a cluster role binding that said anybody in this group can be a cluster admin. Well, that maps to the ID token where it has the list of groups, which maps back to our user identity that has our roles. So now everything kind of ties together. So coming back here, we're going to go ahead and run this kube control command. Now, you can't access this cluster right now from off this box. So in order to not blow up our kind config, so I'm just going to say let's point our kube config at another file. So if I do kube control get nodes, temp-r doesn't exist yet. So now we're going to paste in what we got from OpenUnison, and it set up everything for us. So if we look at temp-r, you'll see that the certificate authority data is already in there, the server's in there, the identity is in there, the ID token's in there, the refresh token is in there, everything is set up. So now we can execute, well, shit. Did I get logged out? All right, let's try this again. Save, let's go with token, kube control command, kube control get nodes. Okay, cool. So must have just had an expired token somewhere. No big deal. That's a great thing. Logged in, logged out. And we're now doing this as M. Mosley, not as cluster admin. So now, next chapter when we get into RBAC, we talk about audit logs. We're going to see that everything I'm doing is as M. Mosley. So now that we have our kube control configuration, everything is set. Let's go ahead and log out, right? So the great thing about OpenID Connect is it's got this built-in refresh mechanism, right? So if we look at, let's look at temp-r again, we've got this built-in mechanism using a refresh token. Now this refresh token is opaque. It doesn't really mean anything, but it's single use. So after about a minute, kube control is going to go, oh, this ID token is expired. I need a new token, and ask OpenUnison for a new token. This all happens automatically. So if I go ahead and I say get nodes, it just keeps happening behind the scenes as you work. But my session's done, I want to log out. So here's the really cool thing. I've logged out. This bearer token's only good for a minute, and then it has to be refreshed. But by logging out, I've actually deleted that session. So we're going to give this a minute. Excuse me. And we're going to go ahead and give this a moment. And you can see up here, it shows the time. And there we go. The token expired. And when Kubernetes tried to get, or when kubectl tried to get a new token from OpenUnison, that failed. So that works great. We're now tied in with OpenID Connect. Whenever you are launching a cluster, if this is an option, this is going to be your best option. It gives you the most bang for your buck. You've got a direct integration, and there's a lot of flexibility. So now that we have that set up, what's next? Well, what if your cluster's running in the cloud? Whether it's EKS, AKS, GKE, DigitalOcean, Civo, doesn't matter. That ability to log in to your master node and update your API server flags doesn't exist. A little bit for EKS, but chances are it won't work for you anyway, because you need to have a publicly facing identity provider for that to work. And so how do you do authentication for managed Kubernetes? Well, one option is to use the Cloud IAM vendor's identity system, and that's a very popular option. What you will often find that you'll run into is that with that option is that the cloud team doesn't want to be the one responsible for figuring out who has access to what. And so they get tired of that very, very quickly. And so to make it a little bit easier, they want to let teams delegate identities internally. Excuse me, very dry today. So how do you then handle that? Well, that's where impersonation comes in. Put a reverse proxy between the user and the API server. The API server gets authorized to be able to do impersonation. Instead of your OpenID Connect going to the API server, it goes to that reverse proxy. The reverse proxy, in turn, will then say, okay, I'm going to impersonate this user. So this way, you don't actually have to edit the API server flags. So this talks about impersonation, talks about the security considerations. Okay, cool. So what we're now going to do is update our cluster. I'm on page 197, this time for impersonation. So there isn't a lot we need to do. First thing we're going to do is we're actually going to delete our secret for Unison TLS, or for, let's go back to that. Oop, there we go. So what we wanted to do is we wanted to delete our TLS certificate because that certificate didn't have the right names in it to support an additional host for the API server. Now we have already configured our chapter 5, OpenUnison.yaml. So we've already configured our networking configuration here for OpenUnison host, dashboard host. Now we're going to add an API server host. And then we are going to enable impersonation. So what this is doing is this is saying, okay, instead of assuming we're going to talk directly to the API server, we're going to set up this reverse proxy. We forked a project, we being Tremolo Security forked a project from JetStack called kubeOIDC proxy. That is that reverse proxy. It will actually validate our OIDC tokens and then go ahead and inject the impersonation headers needed to do the impersonation. And so now that we've done that, we can go ahead and let's redeploy. So Helm, upgrade, Orchestra, Tremolo, Orchestra, and OpenUnison F Chapter 5, OpenUnison values. So Helm is checking the values and saying, oh, we now want impersonation. So let's go ahead and redeploy this chart such that impersonation will work. And if we take a look at kube control, get pods, and OpenUnison. So now we'll see that 2 new pods are here. We've got a new Orchestra pod, and we have this Kubo ADC proxy pod. And so it is, this is going to be our reverse proxy that sits between our users and our API server. And so next, let's go ahead and do the same thing to the login portal. And so this is reconfiguring the OpenUnison application configuration to work using impersonation as opposed to using OpenID Connect directly with the API server. So let's take a look at how we're doing. So everything's running, right? Our Kubo IDC proxy is running, our Orchestra is running. Now, one thing that will also be running is our dashboard. That's because the dashboard knows how to work with impersonation. Trimble Security donated that code several years ago to make that work. We'll see the same technique used again once we'll dive deeper into it in Chapter 7 when we talk about the security of the dashboard, and we'll talk about it again once we get to Istio when we talk about Kiali. So now that that's done, let's go ahead and log in. Oops. Yeah, here we go, 104. All right. Let's log in again. And let's go to the dashboard. We'll see the dashboard still works. That hasn't changed. But you see here, it knows that I'm at Mosley. If you remember when we originally got the dashboard working in the previous steps, it just said auth header logged in. That's because the dashboard doesn't actually know who the user is. It's just blindingly passing it through. Whereas now we actually are introspective. We know what the identity is supposed to be, so we show it to the user. But I am, in fact, interacting with the API server as I'm Mosley. Here's the next bit that's cool, is let's grab our kube control command. And I'm now on my local browser. Export kube config gets temp h. Kube control get nodes. There's nothing there, right? Kube control get nodes. And there we go. I'm now able to access my cluster remotely through the OpenUnison reverse proxy via our Nginx reverse proxy. And I'm able to do whatever the heck I want to do, right? So kube control get pods and OpenUnison. Kube control exec ti. Let's go ahead and enter our pod. So I'm now logged in just as if I had direct OIDC access. So that takes us through impersonation. We then talk a little bit about how to set up impersonation without OpenUnison. So if you wanted to set up something on your own, there's nothing that says you have to use OpenUnison for this. So next time we're going to talk about authenticating from pipelines. And there's a lot there, so we'll want to do that justice. Thank you for joining us. If you like what you're seeing and you haven't picked up the book, would love if you did, obviously. And then also, if you're enjoying yourself with these videos, smash that like and subscribe button. It does make a big difference. Thanks, everybody. Have a great day.